Welcome to this video lecture on normalization process. I am Smita Suresh Daniel, Assistant Professor from St. Thomas College, Bhilai. This is a video lecture for MSc second semester, Paper 1 RDPMS and Unit 5. In this video, I will be discussing about the various normal forms 1NF, 2NF and 3NF in detail. Before that, I would like to explain to you the concept of normalization. Normalization is actually a process of organizing data in the database. It is used to minimize redundancy and eliminate every kind of anomalies. There are various types of forms in normalization, that is 1NF, 2NF, 3NF and BCNF. Each has its own rules and regulations to follow, but every table in the database should at least follow the first normal form always. Also, it is the first step to move to the second and to the third normal forms. Let's see how to do this. These are the various rules for normal forms. The 1NF requires relation to be in atomic values. The second normal form should have all non-key attributes to be functionally dependent on the primary key. Third normal form should not have any transition dependency, and the fourth normal form is Boyce-Codd normal form and has no multi-valued dependency. Let me explain to you the first normal form in detail. The first normal form has certain rules, like the 1NF should contain atomic values. It should only hold single valued attribute, and also it disallows multi-valued attributes and their combination. Let me explain this with an example. This is an employee table which is not in 1NF. Let's see the rules. According to the rules, EMP ID, EMP name, EMP phone and EMP state. These are the various columns which have different names. All the data types each column has its own data type. There is no mixture of data. Only problem in this employee table is the EMP phone number. This cell contains more than one data and it is not atomic. So this has to be changed. This violates the rule. Let's go to the table which is now converted into 1NF. Here we see that EMP ID, EMP name, EMP phone and EMP state all are rearranged in this manner. Here each column contains atomic values. All the columns contain atomic values. Second, each value is of same type in a column. They are not mixing the data together. Order do not matter in a column. Hence, it aims to make the table scalable and retrievable. Let's move to the second normal form. For the table to be in second normal form, first of all, it should be in 1NF, and the second important condition is that it should be functionally dependent. The non-key attribute should be functionally dependent on the primary key. Functional dependency is a relationship between the two attributes like primary key and a non-key attribute. Here we see that y is functionally dependent on x. This means that x uniquely determines the value of y. Every non-key attribute must fully be dependent on the primary key. Let me explain with an example here. Let's assume a teacher table in which a school should store the data of teachers and the subjects they teach. In a school, a teacher can teach more than one subject. Here the teacher ID is there, subject is there, and teacher age is there. We see that teacher age is a non-key attribute, and this teacher age is dependent on teacher ID, which is a proper subset of a candidate key. And subject is also dependent on teacher ID. So this violates the rule of 2NF. Hence, this particular table has to be converted into 2NF and decomposed into two tables, teacher detail and teacher subject. In teacher detail, we see that the teacher detail and teacher age are combined together to form a table where teacher age is functionally dependent on teacher ID. Similarly, teacher subject is another table where teacher ID and subject are functionally dependent. These two tables are combined together to form into a 2NF normalization. This perfectly applies all rules. Now we go into the third normal form, 3NF. A relation will be in 3NF only if it is in 2NF first of all. And there is no transitive dependence for an attribute here. Again, transitive dependency I will explain with an example. In this table, employee detail table, we have the following columns. Here we see that EMP name is functionally dependent on EMP ID. EMP zip is also functionally dependent on EMP ID, but we see that EMP state and EMP city are directly functionally dependent on EMP zip, and EMP zip in fact is functionally dependent on EMP ID. So we can call these two columns to be transitively or indirectly dependent on EMP ID. This is known as transitive dependence. This should not be there in any table. According to the 3NF rule, this violates the rule. So the transitive dependence of EMP state and EMP city should be removed from this table. Let's see how we can remove this and make it into a 3NF. Employee table and employee zip table are created. In the employee table, only employee name and EMP zip is put, where all the non-key attributes, these two non-key attributes are functionally dependent on EMP ID, and in the second one, EMP state and EMP city is now functionally dependent on EMP zip. So we see that nothing is transitively dependent. EMP zip has a separate table and employee table is separated. Hence we see that both the tables are in accordance with 3NF. Thank you.